We're going to start our section on trig, or our unit on trig here. And we want to start off today by talking about angles. And specifically today we want to look at to find the measure of an angle. How do we measure them? And we're going to use radians. So first let's talk about an angle. Now, we have an angle here that you may remember from geometry. And a couple things we want to label here. Here is the vertex of our angle. We call this our initial side. And then up here, we call this our terminal side. Because usually when we have an angle, the way we draw it is it starts here and goes up to there. So that is our angle. If we want to find the measure of the angle, that is the part we want to measure. Now, if we wanted to show the other angle, we would then draw the line this way, and that blue line would be a different angle with a different measure than the green line. Now, what we do when we draw this is we're going to combine this with a lot of our algebra and other things. So we want to draw it on our XY plane. Think this is our X's, this is our Y's, and we put our initial side along the positive x-axis, and then we draw our terminal side wherever that angle may go. If we have a positive angle, it's like the red there, goes that way. So that's when it's positive. If it's a negative angle, we go the other way. So if we have a positive angle, we go counterclockwise. A negative angle, we go clockwise. And they always start from this positive x-axis right here, which is always our initial side. And then we end up wherever our terminal side is. And what we want to talk about is how do we measure that? What's the size of that angle? And to do that, we're going to define something that's called the radian measure. Now let's show you where that comes from. First off, we're going to draw a circle. And for right now, don't pay attention to the dots. But this circle has a radius of 1. So you can see it goes through the point where it intersects the axes is at the point 0, 1, 0, negative 1, 1, 0, and so forth. Now, if we look at this circle, we would say that this distance from here to here is 1, a radius. But we would also say that the distance from here to here is also 1. Both of these are 1 because we have a unit circle. Okay, circle might not be perfectly to scale, but you get the idea. Now, what we want to look at is our intersecting arc. Now, what does that mean? Well, between these two radii, we have this arc right here. I'm drawing in red. Not very well. Try it again. We have this arc right here. And we want to find the length of that arc. So imagine you were to start right here and you want to walk along this arc. How far would you go? What would be the distance? Well, if this radius is 1, and this is 1, and this arc is 1, so if you walk the same distance from the origin to here, from here to here, and along this curve, they're all exactly 1. The measure of this angle here is 1 radian. That's the definition of 1 radian. 1 radian is the measure of a central angle that intercepts an arc on a unit circle of length 1. So the important thing here is, one of the important things, is this arc length is equal to our central angle. So if this is 1, and then I would go here and have a length of 2, so my distance all the way back is 2. Then this angle here would be 2. My arc length matches my angle. So if we look at this, now what I've done is I've taken that distances around my unit circle and I just labeled it more closely. You can think of just taking the number line and wrapping it around the unit circle. So radians 2 is going to be, remember now first, here's my initial side. For an angle of 2, it goes right there. That's an angle of 2 radians. To find a 3.5, I go to 3.5, and there is an angle of 3.5. Here's my angle of 2. If I want to go negative 2.5, okay, now negative, remember, means I'm coming this way. How I do that is I find a positive 2.5, I drop straight down, get about right there, and there is a negative 2.5. Last one let's do is a negative 1.2. 1.2 is about right here, drop straight down, it's about right there, so right there is a negative 1.2. So you can see our angle is just determined by our distance around the circle. So what's our distance all the way around the circle? That is called the circumference. And we know that the circumference of a circle is 2 pi r. So the distance all the way around the circle is 2 pi r. Now, our radius is only 1. So radius of 1, we don't really worry about that. So our circumference all the way around the circle is 2 pi. So what is our angle all the way around the circle? 2 pi. Now, instead of going all the way around the circle, we only go halfway around. It's going to be half of 2 pi, which is just pi. If we want to go a quarter of the way around the circle, to there, that's going to be half of a half. So I had to take pi and I divide it by 4. If I want an eighth of a circle, that's going to be here. I go to there, I divide this by a half. I'm sorry, wrote down the wrong thing. Erase. Stop. Typo. Pi over 2 for a quarter of a circle, the green. And then the black is half of that for an eighth, which is pi over 4. Let me erase these. So, this is pi. Let me split that into thirds. So this is our 1/6 of a revolution. So if this is pi, I'm breaking this into 1, 2, 3. So for 6, I get pi over 3. Now, if I want to divide this circle into thirds, 1, sorry, put that one in the wrong spot. One, 2, 3. There we go. Now I'm going to take and divide. all right. Let's try this again. All right, let's try this here. So we did our pi over 2, which was a quarter way around the angle. Now we want to cut that in half. That will then give us an 1/8, which is pi over 4. Now, let's look at once again, our angle of pi, halfway around our circle, and let's divide it into 3 sections. 1, 2, 3. So that tells me that that angle is pi over 3. And if I divide that, again, that's going to give me pi over 6. Now let's actually fill in, going around our circle here, with our angles on the unit circle. Now, first off, we have 2 pi, which is all the way around the circle, which is to right here. So we have 2 pi or 0. If you don't go anywhere, it's 0. If you go all the way around, it's 2 pi. And I'm not going to draw that in the middle, as it makes it messy. We then have pi over 2. That's a quarter way around, and we have pi, which is right here. But let me get you to think about it a little bit different way. This is pi over 2. This now is 2 pi over 2, which is just pi. This is 3 pi's over 2. And finally, one more time, 4 pi over 2. Now you can see, we really don't need 2 pi over 2 because we've already got that at pi. We don't need 4 pi over 2 because that's already at 2 pi. But we do need 3 pi over 2. Now let's go around and put the next one in, this dot. This is half of the pi over 2, so this is pi over 4. 1 pi over 4, 2 pi over 4, I'm just going to write this down so you can see the pattern. 3 pi over 4, 4 pi over 4. However, we don't need the 2 pi over 2 or the 4 pi over 2 because once again they simplify. But if this is 4 pi over 4, this would be 5 pi over 4. 6 pi over 4, that simplifies. 7 pi over 4. Let's do our next one. Pi over 3. 2 pi over 3. 3 pi over 3. That's just pi. 4 pi over 3. 5 pi over 3. 6 pi over 3. We're back at 2 pi. Now, for the last set of dots, these are all going to be pi over 6s. But let's do a little bit different. This over here is 6 pi over 6. And we could count 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. But if this is 6 pi over 6, if we go back 1, that's 5 pi over 6. If I go forward 1, that's 7 pi over 6. Over here, 2 pi is 12 pi over 6. If I go back 1, that's 11 pi over 6. And now I end up with all of my radian measures on my unit circle. You can kind of see the pattern. All of these dots are pi over 6s. 5 pi over 6, 7 pi over 6, 11 pi over 6. All of these dots, pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. All of these dots are pi over 3. Pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. And finally you have 0 pi over 2, pi over 2, pi, and 3 pi over 2. Those are all points all the way around the unit circle. Now, as we move on, we want to keep those in mind. Oops, don't want to move it. But we also want to go back and keep these in mind. These kind of radian measures. If you combine these, if you got out your calculator and looked at it, pi is 3.14. You can see here, 3.25, 3.14 is in the middle. If you looked at pi over 2, 3 pi, 3.14, 3 over 2 is a little bit more than 1.5. You can see 1.5 is right there. 2 pi, 6.28, 6.25 is right there. So you can see most of these are pretty close. 4 pi, 4 times 3.14 is a little bit more than 12. Divide by 3 is a little bit, 12 something, or add by 3 is about 4, and you can see right here is about 4, which is about 4 pi over 3. So you can see how these are connected. Okay? That will be helpful as we go forward on the next couple of problems. First one is we want to estimate the measure of this angle. So we want to estimate the measure of that angle. Now, if we go back to here, that's going to be, let's say, about here. But it's going that way. That tells us it's negative. When it's negative, you have to go up. So it's about right there. So estimate our angle is about negative 2.25. Determine what quadrant, 5 pi over 7. Now let me just draw my unit circle here so we can kind of talk about it. Well, I know this angle is 5 pi over 7. Excuse me, 5 pi over 5. I know all the way around over to here is 10 pi over 5. It's 2 pi. So 7 pi over 5 is going to be somewhere in here, which is in the third quadrant. Let's look at another one. Sketch the angle in standard position. Standard position means on our x and y plane. So we start here, and where does our angle go? Well, we know 5 pi over 5. So there. 10 pi over 5. It's back to here. Now, if I keep going, this is over 2 pi. If I go 5 more to here, I now have 15 pi over 5. Notice I'm able to label this angle 2 different ways. It's 5 pi over 4, 5 pi over 5, or 15 pi over 5. Now, if I would go all the way back, I would now have 20 pi over 5. But I don't go all the way back. I'm at 15, so I need 2 more, which is a lot like what I did in the last one. When I had 7 pi, which was 2 pi over 5 more than 5 pi. So I end up with actually, this angle is in the same place. This angle and this angle are the same. So 7 pi over 5 and 17 pi over 5 were actually the same exact place. All right, first homework, angles, number 1.